All right, so here we go. We've got our last video of the chapter. Isn't that exciting? And what it is it's going to be about vertical motion. Now, we've kind of actually already talked about that. If you remember when we talked about objects dropping. So if you have an object that drops, meaning you did not push it, it did not have force behind it, it just gets dropped, then what we do is we use that formula h equals negative 16t squared plus s, right? Well, I'm going to add to that. I'm going to say, what if there was force behind it? Okay, what if it was thrown or pushed or something along that line? So I'll just say object thrown. Okay, the formula is actually very similar. It's going to be h equals negative 16t squared, and it's going to have a plus at the plus s at the end. So it looks just like that except for what's in the middle. And the middle is going to be vt. Okay, so that's the addition, is this vt. And let's talk about all of this stuff stands for. Even if you remember that last video, I just want us to remember what things are. So go back. Let's start with, so if you don't have your notes out and going, you should, because you should be writing all of this down that's on the screen. This is going to be very important. Let's start with our h. So that's right there and there, okay? H is the ending height. Whatever story you're given, where is it ending? Is it ending on the ground? So then it would be 0. Is it ending on a 5-foot person's head? Then it would be 5. Like, what is that ending height? Plug that in for h, okay? Then we have S. Okay, they both have an S. S is the starting height. So look back at your story. Where did it start? Okay, what was its highest point or lowest point, depending on what's going on? Maybe it was being thrown up and it started on the ground. Maybe it was on top of a building or on top of a tree and it fell down. Whatever it is, what is its starting height for S? T is the one you're usually solving for. Okay, so T is the X basically in our usual problems. So T is the time in seconds. So whatever that is. And then you have one more, and that's the V. And so V is that initial velocity. Initial, I can't spell initial. Initial velocity. So what did it start with? Was it given a throw, that kind of thing? If you're throwing something up, if it has initial velocity going up, it's going to be a positive number. But if it had initial velocity pushing it downwards, it's going to have a negative number. So you have to pay attention to that when you plug in your number. All right, so let's go ahead and try an example. Make sure all this is in your notes, though, before you go forward. So the example is, you're jumping off a 15-foot diving board with an initial upward speed of 3 feet per second. How long will it take you to hit the water? So we have variables we have to fill in for. We have H, we have S, we have T, and we have V. So let's say it again. It's a 15-foot diving board. That means you've got your water, you've got a diving board that is 15 feet off the ground, or off the water. So the water is considered 0, ground 0. So then 15 feet would be where you start at. So you're starting up here and you're going to jump in the water. So this is 15 feet is your starting height. The question is, when do you hit the water? So that would be the ending height is 0. The initial upward velocity of 3 feet per second means that your initial velocity is a positive 3. And we're trying to find time, so we leave that as a variable. So you first want to be able to identify these things before you even start. Then we plug it into our formula. Remember, that's h equals negative 16t squared plus vt plus s. So h is 0. V is 3 plus s is 15. Okay, so we plugged it in, and now you just use your quadratic formula, which I'm not going to waste your time watching a video to watch something like that again, but use your quadratic formula to figure out then when you hit the ground. And you're going to get a positive answer, and you're going to get a negative answer. And I'm pretty sure, unless it's a magical place that you are not going to go back in time to jump in the water. So it's not going to be the negative. You're just going to go with your positive answer, even though you'll find both. Just cross off your negative one. Let's look at another example. So this one says, from the top of a 40-foot cliff, so you've got a cliff that's 40 feet up in the air. Okay, you throw a stone downwards at 20 feet per second into the water below. So apparently there's water down here. Okay, how long will it take for the stone to hit the water? So once again, we fill in for our variables, h, s, v, and t. Our starting height is up on top of the cliff, so that would be 40. Our ending height is in the water at ground zero. Our velocity, you're throwing it downwards, so that would be a negative 20 feet per second. And our time we don't know, we're trying to find, so that'd be t. So again, h equals negative 16 t squared plus vt plus s. H is 0, so we're plugging in now with what we know. H is 0. We don't know t, so we'll leave the t there. V is negative 20, so minus 20t, plus, and then s is 40. And once again, we use the quadratic formula to answer it. Again, you'll get a positive and negative answer. Ignore the negative answer because you're not going to go back in time with that stone. Just use your positive answer.